This video is an introduction to mapping. And by definition, mapping is a relation between two sets. Any two sets of things, the relationship between them we say that is mapping. Now, I'm going to be using an example of friends to show that we could have sets of things that are related to many other things. Let's say the friends, let these letters A, B, C, and D represent their names. This could be Anita, this could be Bella, this could be Cindy, this could be Doris, any name. So let it just represent the names of 4 friends. Now, let's say these 4 friends have different occupations. Let's say A is a teacher, B is a driver. Okay, that's D. Let it not confuse us. So D works at a security outfit. So S. C might be what again? A marketer. And then D might be working as an executive officer in an organization. Okay, so we can see that this is a mapping, the relationship between friends and what they do for a living. These same friends, A, B, C, and D, might as well have some colors of materials picked out, like set for them to choose. Let's say there is an orange color, there is a blue color, there is red, there is pink, there is white, and of course there is black. So they've been asked to select. Let's say A prefers red, B picked out white, D picked out pink, and C picked out blue. So we can see, and then they left out the black and the orange. We can see this is also a mapping, the relation between friends and the colors they prefer when it's presented to them. We can as well have these same friends, A, B, C, and D. And then what they weigh. Now, let me not use numbers that are big. Let me just use 1, 2, 3, and 4. So let's say these are their weights of these 4 friends. So A is weighing 1 kg. Of course, that's nobody's weight, but let's just use that as an example. So we can see mapping could be relationship between anything. We have so many relations. Now, let's also talk about function before we now get into how do we identify, since there are many relations, how do we identify which one is a mapping and which one is not? Now, a function is a mapping. Every function is like they are mappings. A function is a mapping in which its codomain is made up of a set of numbers. Now, I've introduced something new, codomain. For each of these mappings, this first list here, or this first set here, that is the domain. So this is the domain, and then this is the codomain. This is the domain, and this set is the codomain. This is the domain, and this is the codomain. So among all these 3 mappings we have here, this is a function. So a function is a mapping in which its codomain is made up of numbers. Okay, so having set that aside, now I'm going to be using this particular illustration. Let it always run through your mind whenever you're given a set of relations and you're asked to find out which one of them is a mapping or which one of them is not a mapping. Now we said, let these be the names of friends and let these be their weights. Now for every human being, you must have a weight. No matter how little or big you are, you have a weight. There is no human being without a weight. What does that mean for us? What it translates to is that when we see a mapping, every domain must have a codomain that it is related to. Right? Good. Now, the second thing we have to understand is that there is no human being that has 2 different weights at a point in time. Like at a point in time where you go to weigh yourself, it's only one weight you have. What does that mean for us? Every domain must not, like, there is no domain that a member of the set of a domain that should be mapped to more than one codomain. So B cannot weigh 2 and 3 at a time. B is weighing any of these numbers at a time. Now, B and C could weigh the same thing. 2 people can weigh the same thing. Everybody in one particular group can weigh the same thing. Maybe they are trainers or something, and then they must maintain their weight. Now, we have seen the rules. That is what we are going to have in mind when we look at examples. When we find out, is this a mapping or is this not a mapping? Now, we have these questions. Which of the following representations are mappings? Now, this is what we call arrow diagram. It's one of the ways of representing mappings pictorially. Okay, and this represents the domain. This represents the codomain. Now, looking at this A option, what we have to have in mind is that these are people and these are their weights. That is just the mentality we have to, so as to be able to always pick out the ones that are mappings or the ones that are not mappings. Okay, so we have that each of them has, each of these people has a weight, right? Good. And then A and B happens to weigh same thing. It doesn't matter. And then this is left. Of course, in a group of persons, you can have a list of weights, and then there could be a weight that you can't find anybody that weighs that thing. So this doesn't really matter. All it covers is that for every element in the domain, it has a codomain that is mapped to or related to. And then that there is none here that is related to 2 elements in the codomain. So that is all. That means this is a mapping. Now let's look at the second one. We can see every one of them has a relation, like is mapped to the codomain, right? But we can see that this is related to 2. So no human being at a point in time has 2 different weights. Therefore, this has disqualified this relation as a mapping. This is not a mapping. Now let's look at C. Okay, every one of them has, and then so this is just like the first one. This is also a mapping. No, we can see that H doesn't have, so H doesn't have any codomain it is mapped to. There is no human being that doesn't have a weight. Therefore, this is not a mapping. Okay, then for this, every one of them has a codomain, right? Okay, and they are all same. Of course, it's possible to, like we said earlier, that it's possible to see many people that have same weight all over the world. There are many people that weigh 50 kg together. So this doesn't disqualify this. In fact, this is a type of mapping. We'll see that later. It is called constant mapping, whereby every member of the domain has the same codomain. Okay, so we've seen that this is a mapping, this is not a mapping, this is not a mapping, and this is also a mapping. Now let's see this. Which of the following illustrates a function? Now, the first thing we have to look at is the codomain. We can see that the codomains are made up of numbers. Therefore, all of them could be functions. Now, we say that a function is also a mapping, right? So those rules for mapping are also applied here. Okay, we can already see every one of them is related to the codomain, the set of the codomain. So we can see that this is related to 2. No human being has different weights at the same time. So this is disqualified. We can see in B, yes, every member here is mapped out to an element of the codomain. Very good. So this is a mapping. This is a function. Okay, it's also a mapping too. Okay, we have this. Every one of them, yes, but this has 2, right? So this is disqualified. Then we look at this. This is also disqualified because not every member of the domain is mapped out to a member of the codomain. So A and D. So this is not, this is not, this is, and this is not. So B is the only function that we have here. So I want you to practice with just the few things we've learned, be able to identify mappings and functions when you see them.